Today we'll be talking about VisualCAMc, the full cloud-based CAM application for Onshape. So as you can see, I currently have a part modeled in Onshape, and I'm going to go into VisualCAMc by selecting Add an Element and choose VisualCAMc. So this will automatically launch a new tab right next to your Part Studio tab in Onshape document, and you'll see that the part is loaded into VisualCAMc, and the interface, the CAM interface appears right in a browser. So I'm running on a Chrome browser, so you could be using any browser, any operating system, and you can program your toolpaths directly from a web browser here. So the typical workflow in VisualCAMc is working your way from left to right as you access these menus. Your CAM browser appears over here on the left pane, and the first step is to define your machining process. So you would go to Machine, and you would select the coordinate system for machining, and by default the coordinate system is oriented in the same orientation as the world coordinate system as you have established in the part. So you can specify the orientation and then select Save, and this establishes your XYZ orientation, or the coordinate system orientation, for milling this part. And the next step we're going to do is select our post processor in here. So we go into Post, and we can select a post processor that you may already have pre-selected, or you can choose from a list of post processors in here, and you can pick one from the list. So we currently have over 300 different posts that are included in our standard post library. So I'm going to pick a post in here, select Close. The post processor is set to a Fadal CNC machine. In the next step, we would want to go ahead and build our stock material. That would be the workpiece you're going to be selecting or starting with to machine this part. So selecting stock displays your stock dimensions in here. You can see the XYZ extents are automatically computed based off the part geometry that you're working in, and you can also specify offsets in X, Y, or Z. And in this particular example, I'm going to add a 50 thousandths offset along the Z-axis. So we would like to first face it down, so the material can, the part can be, stock can be faced down to the height or the thickness of the part. And you'll see that the stock is now displayed on top of the part, and there's an additional 50,000 stock being left in here. In the next step, we're going to establish the work 0, or your work coordinate origin of the program 0, and this can be done by selecting work 0. And in this particular step, you can set the origin to your stock box, or you can set it to the part extent, which is the part box. We're going to pick Set to Stock. We'll pick the 0 face to be the highest face, the top face of the stock, and for the 0 position, I'm going to choose the southwest corner, which would be your lower left corner. So you'll see that the coordinate system triad appears at the top face of the stock and the southwest corner, and selecting Save creates your work 0 and is listed in your machining browser under the machining job. We are now ready to program our toolpaths in here. So under the Tools tab, we have currently a set of tools loaded, and we'll go through the programming steps here. So as this part is prismatic, where there are no sculpted surfaces or sculpted bottoms, we're going to use a 2.5 axis or 2-axis programming method to machine this part. So I'm going to go into 2-axis, first start with the facing operation in here. And under the facing operation, I'm going to pick a tool. I'll pick a face mill. I can always double click to make edits or changes to the tool in here, and hit Save to save the changes. Establish my feeds and speeds, set the spindle speed, cut parameters, your cut feed rate, engage and retract feed rates. And you can always set these parameters for each and every operation that you're working on in here. So I'm going to set my cut feed rate to be 20. I'll change the engage to be 10. We'll read the retract at about 40 inches per minute. In the next step, you can establish your clearance, which is your safety plane or the safe Z height for transfer motions. I'm going to leave this as automatic. And then we'll establish our cutting parameters, where you can set your tolerances, your stock allowance, your cut patterns, your cut directions in here. You can also control your step overs and all the additional parameters. You can also establish your cut levels. And I'm going to pick this boundary here by right-clicking to select a chain, so it automatically picks a chain of face edges from the part. And then we'll establish our entry and exit. I'm going to establish the entry and exit using lines and arcs, specify the parameters for these as well. And you can also set your exit parameters under the Exit tab, and pick Generate to compute your toolpath. So your toolpath is now being generated on the cloud, and delivered back in real time. As you can see how quickly, how fast we were able to compute the toolpath. So there's the scalability available to you based on the complexity of the part. So selecting simulate will provide you an animation of your toolpath we just programmed. So there's our facing operation. The next thing I'm going to program is a pocket operation. So as this is a step pocket, I'm going to use a two-step process, use two different pocketing operations. In the first pocketing operation, I'm going to pick a tool. We'll use a 3/4 inch end mill for the pocket operation. We'll specify our feeds and speeds, clearance, and then go into the parameters. The workflow is exactly similar to what we did on the previous step, the establishing of feeds and speeds and clearance. Now I'm going to right-click on this edge to pick a chain, so it automatically auto-chains the face edges. Specify the parameters for your pocketing. You can set your tolerance, your stock allowance, and then here you can choose from the different cut patterns. I'm going to use the high-speed cut pattern. This is like your adaptive cut pattern, also known as tricaudal cut pattern, so we call it high-speed cut pattern. Specify your cut direction. Control your step overs in here. You can establish your cut levels, where you can specify your total depth. Your depth per cut can also be set right in here, and selecting generate creates your toolpath. So your pocketing toolpath for the first step of the pocket is generated. We'll go back and repeat the pocket operation again to program the next level in here. We'll still use the same tool, so you can see the tool is pre-selected. I'm going to use in the cutting parameters, I'm going to pick an offset cut pattern in here. In the cut levels, I'm going to pick the face edge at the bottom of the pocket, which is at the floor of the pocket. So right-click will select the edge, chain of edges, and then pick Generate Toolpath. So the toolpath is computed, and the toolpath is previewed once it's generated. In the next step, we're going to program these holes in here. So we'll use a hole profiling operation under 2-axis. We'll pick hole profiling. I'm going to pick a 1/2 inch end mill, establish my feeds and speeds and clearance. In the cutting parameters, we could specify the cut conditions in here. We can select these two hole features, specify the hole depth, and any additional parameters, where you can also control the helix parameters, and then pick generate to compute your toolpaths. Now finally, we're going to program a drilling operation to drill those 4 holes on the top face of the part. We'll select hole machining and drilling. We'll pick a tool for drilling in here. So I have 2 different drill tools loaded. So I'm going to pick a 1/4 inch drill, establish feeds and speeds and clearance. Under cutting parameters, I can specify the drill depth, and I can also select the type of drill, whether you want to program a standard drill, deep drill, countersunk, break chip, or you can even have user-defined drill cycles. I'm going to go with the standard drill in here and select the drills by selecting the features by just picking the edges of the hole right here. So I have those 4 holes selected. I'm going to add tooltip to drill depth, so it'll actually compensate for the tip of the cutter to make it a through hole. I can also apply a sorting in here to sort the drill in a sequence, and then pick generate. Your toolpath is now generated. You can run a verification in here, right-click simulate, and there's your verification toolpath animation. Now you could post each of these operations out individually. If your machine does not have a toolchain, if you need to post them individually, you can right-click and select post process. Your posted code is automatically downloaded to your computer, and there's your posted code for the drill cycles. You could also post all the operations to one posted file. Just select the setup, right-click on the setup, and select post process. This would automatically download your posted output file, and you'll have all the operations with your tool changes, starting with the first tool and all your subsequent tool changes. Now the posted code is now ready to be transferred out to your machine controller.